I also think that this gives you a lot of tools to think through trade-offs, right? They're very, very clear about the fact that everything in software architecture is a trade-off.
Hey there, welcome to Book Overflow. This is the podcast for software engineers by software engineers dedicated to reading the best technical books in the world as an effort to improve our craft. I am Carter Morgan. I am joined here, as always, by my co-host Nathan Toups. Nathan, how are you doing?
Doing great. Glad to be
Great.
here.
Yes, me too. We are very excited about the book this week. It is Fundamentals of Software Architecture by Neal Ford and Mark Richards. We're going to get into that in just a sec. We just want to say once again, thank you to all of our listeners, our subscribers. Really happy about the early response we're seeing, especially on YouTube, on Spotify. Thank you so much for tuning in. Please go to bookoverflow.io to see the upcoming book schedule. And if you're listening right now, rate us 5 stars, like and subscribe. All those things you usually hear. It really does help boost us in the algorithm. And we know a lot about algorithms as software engineers. So do your part. Help us game the system a little bit. But like I said, we're going to read today Fundamentals of Software Architecture. We'll give a quick overview of the authors and the book, and then we're going to talk about our general impressions on it. So this is written by Neal Ford and Mark Richards. Here are their descriptions on the book. It says, Neal Ford is director, software architect, and meme wrangler at ThoughtWorks, a software company and a community of passionate, purpose-led individuals who thinks disruptively to deliver technology to address the toughest challenges, all while seeking to revolutionize the IT industry and create positive social change. It says Mark Richards is an experienced hands-on software architect involved in the architecture, design, and implementation of microservices architectures, service-oriented architectures, and distributed systems in a variety of technologies. And just as a note about ThoughtWorks, I was on Twitter. I think I was running the Book Overflow pod account, and or maybe it was just my personal account. Anyhow, I responded to, I think it was Martin Fowler actually, about refactoring. Just said, hey, I really love this. Thanks for writing it. And a random account that I thought was just like, I don't know, some meme account or something liked it. It was ThoughtWorks. And so I when I was reading this, I was like, oh, hey, that's like a real thing. Oh, hey, that's Neal Ford's business. So Neal Ford, thanks for, I'm sure it wasn't you, probably one of your social media guys, but thank you so much for liking my tweet. It means a lot. Okay, and then the Amazon blurb for this book, we just get it right from Amazon.com. It's a quality company. It says, salary surveys worldwide regularly place software architect in the top 10 best jobs, yet no real guide exists to help developers become architects. Until now, this book provides the first comprehensive overview of software architecture's many aspects. Aspiring and existing architects alike will examine architectural characteristics, architectural patterns, component determination, diagramming and presenting architecture, evolutionary architecture, and many other topics. Lots of great stuff here. Our show notes are particularly dense this week. Before we get into anything in particular, Nathan, why don't you give me your thoughts on just general impressions on the book? And I should mention before we get started, this is part 1 of part 2. We have read the first half of this book. I believe we're through chapter 13. Page 197 is where we stopped. So Nathan, give me your impressions on the first half of Fundamentals of Software Architecture.
Yeah, so unlike the density of the ChatGPT book that we just read, this one is very easy to read, and it's full of like what I would call like solid and pragmatic advice, not only for software architects, but for anyone in the software industry who wants to think about how these patterns affect our lives. I think that there's a really beautiful sort of through line in everything that we've had on in the first 200 pages on dealing with unknown unknowns. It's a big theme that comes up, and I think leading software to deal with these unknown unknowns is like a very challenging piece. I also think that this gives you a lot of tools to think through trade-offs, right? They're very, very clear about the fact that everything in software architecture is a trade-off. And they put that front and center. And so they never say, don't do this, don't do that. They really say, if you do this, well, this is the repercussions. This is what might happen. This is where scalability might become a problem. But they pointed examples where each of these patterns could be used with success and where they can fail. I also really loved this concept of least worst Like they advocate that you should always try to build the least worst solution, which is funny. I don't know if this is the book that this term was coined or if they just loved running with it. I've used least worst for years. I talk about least worst a lot. So it was a little bit of preaching to the choir, but it was much like clearer thinking and better reasoned arguments for why least worst is such a powerful pattern. So yeah.
I've been enjoying that as we've been reading the books. We're seeing, again, we're not sure if these are where these terms are defined. I'm guessing not for this one, just because this book was written in 2020. But like we found out, like code smells was coined by who did, was that Bob Martin who did code smells, or
I think
where did that come
I
from the
think it was
practice of
Kent
programming?
actually,
Yeah,
right?
yeah, okay, yeah,
Yeah.
Kent, Brian Kernighan
Kent Beck.
Kent Beck and refactoring. Yes. Anyhow, but we're seeing a lot of these terms that kind of float around in the ether and are very popular in our domain. We're seeing the origins of them and the definitions of them. And it's fun. Or at the very least, we're seeing prominent figures in the industry embrace them the same ways we do, which is always a good sanity check on my part. I agree with what you said, Nathan, about everything. I love that this book kind of thrives in ambiguity, or at the very least embraces it, which is not to say that the book is not detailed or specific. It's very detailed and very specific. But like you said, this book teaches the importance of making trade-offs. I've said for years that this field is a field that benefits those who know how to evaluate a good trade-off. I think it's one of the misconceptions about software engineering from people who are outside of it, that they think that there are a lot of right answers in the same way that, like, in physics, there are just some hard laws that govern how the world works. We don't have a ton of that in software engineering. So it really values those who can make trade-offs. I love the quote in this book. I believe it's programmers know the benefit of everything and the trade-offs of nothing. And I have found that to be true. So I like how it embraces making trade-offs. It is a great book for expanding your technical breadth, your exposure to different ideas. We're going to talk a little bit more about what that means, but it's a philosophy I've grown to embrace and have really been enjoying expanding my technical breadth as we read through all these books on the podcast. I love this quote. They say, architecture is about the important stuff, whatever that is, which really sat true with me. And it's really neat. We're only halfway through the book right now, so we haven't gotten the overview of all the different architectures, but we've looked at a couple so far, and it's just really neat seeing them break down the different architecture patterns. And as I'm reading about them, I'm like, oh, I've seen that in the wild, either a product I've used or at one of the companies, a product we've developed. And it's nice to kind of put a name and a face to that architecture pattern, right?
Exactly.
Is it groundbreaking, something I've never known before? No, but it's solidifying my existing knowledge, which I think is really helpful. Well, why don't we start talking about, we can start at the basics with just chapter 1, the introduction. We can talk about what they say are kind of the core expectations for an architect. Here's how they define it. They say, an architect is expected to define the architecture designs and design principles used to guide technology decisions within the team, the department, or across the enterprise. I should mention at the start of the podcast that we're using the term architect a lot. I've found, especially at larger tech companies, that software architect is a bit of an outdated term.
Yeah.
There's usually just increasing levels of software engineer, but that doesn't mean that there are no architects at larger companies, or really any companies, just as you increase in your scope. So when we say software architect, you can imagine senior software engineer, staff software engineer, anyone who's thinking about software architecture. But like they say here, their job is to guide technology decisions within the team, the department, or even across the enterprise. They give 8 core expectations on a software architect. They say that the 8 core expectations, irrespective of any given role, title, or job description, are: make architecture decisions, continually analyze the architecture, keep current with latest trends, ensure compliance with decisions, diverse exposure and experience, have business domain knowledge, possess interpersonal skills, understand and navigate politics. So those are their 8 core expectations. Nathan, that's a lot to choose from. Like we say, this podcast is not a book report, it's a book discussion. So we're not going to give a detailed understanding of each one of those 8, but we do want to talk about which ones stood out to us and why? So Nathan, out of those 8, what kind of really stood out to you there?
So yeah, I actually have real world experience in this area as well. The previous job I had, I was chief cloud architect.
Mm-hmm.
And it actually bled over into a lot of software architecture decisions. I had to work really closely with our principal software engineer. And these areas are really important. I would say the last one really stands out to me, understanding and navigating politics. Um, this is inherently an intersectional job. You're going to be dealing with product managers, you're going to be dealing with executive leadership, you're going to be dealing with the software engineers, and you have to navigate a way of building the tool in a way that you know will serve the business, but also understand the interpersonal skills that are required to pull this off, right? If you understand a core design principle that must take place, you know that, I was working on a FDA regulated medical device. So it was a software as a medical device. And so we had all these regulatory and compliance decisions. So obviously that was a constraint. We had a way that we could build maintainable software, and we had to make a bunch of decisions on like, how would we scale this thing out? How do we, prototype it, scale it, and do these things? And so I had to take on a lot of these decision-making processes. And so this actually, every bit of this spoke to me, and I was just nodding my head the entire time, being like, yes, I wish I had read this book earlier, because we kind of learned these things as we went. And so, yeah, I think that they nail it on these 8 core principles.
I agree. I love the principle of, well, first, I love the principle of diverse exposure and experience. We're going to talk a little bit more about that as we get into technical breadth. I really love the idea of having business domain knowledge. I think this is something I see more junior software engineers make a mistake in, that sometimes people think it's almost like your software engineering experience is more pure and therefore
Yep.
more refined or valuable if you don't have the business domain knowledge, if you're purely focused on the technical side. I haven't found that to be true at all. I agree here. It's so critical to have that business domain knowledge. I just recently started a new job, and I am working with marketing software, which is something I've never had to do before. And it's been really fun because I've come in at the staff level. It's been a different way of thinking where I've spent less time than I would think learning about the technology and how the product is all put together, and much more time trying to understand our users' needs. It's an internal marketing tool. And so I don't really know much about marketing. So I've had to learn a lot about that, which has
Yep.
been fascinating. And I just compare that to the beginning of my career. I worked for a large entertainment company on their theme parks. And I'm a big theme park buff in general. And so I kind of knew a lot about the product there, but I didn't know nearly as much about how what we were doing was enabling the product. I think part of that comes from just when you're more junior, you're just trying to keep your head above water. And so there's really no time to do that. But if you want to be a software architect, especially as you grow more senior in your career and become more comfortable with the technologies you're using, I'd really encourage you to get that business domain knowledge. Really understand not just how your product works, but how your users use it. And also critically, why is it important to your company? Is it making your company money? Is it
Right.
facilitating certain groups that make your company money? I always like to ask the question when I'm analyzing any piece of software, like, if this part of the software were to explode, what would happen? And I think you can ask that about the product you're working on too. Like, if
Yep.
this product didn't exist, what's the impact to the business, right? That analysis is easier at different teams at different companies. Obviously, if you're working on like the checkout system at Amazon.com, you understand pretty intuitively how your product enables the business. But there are lots of internal tools. I think that's what most of us do. We work on internal tooling or smaller parts of the overall product. I think you really got to understand, how is your product facilitating your company's mission? How are your users using it? And you can't be a software architect. You can't progress and become more senior in your career without that understanding.
Yep. I agree. Yeah. To reiterate that business domain knowledge, I had the same observation. The shocking thing to me was the first time I had worked closely with principal software engineer, were how obsessed they were with the business domain knowledge, right? They didn't just breeze over there's this important process and we've already implemented this version of it. No, they got into the nitty-gritty details and exposed patterns and gaps in our understanding that we couldn't have done without them becoming a domain expert in, how a trading algorithm functions, or what it really means to execute, some sort of piece of the business. And that stuck with me as well. I'm in the same spot where you have to get obsessed with the business domain knowledge.
I love what you mentioned about working with kind of those principal engineers, because the principal engineers and the senior engineers at my first job left a huge impact on me. And I think about them a lot.
Mhm.
If you're starting out and you're just at your first job, pay attention to those senior engineers you're working with. Hopefully you work with great people. You will be surprised at how much the rest of your career is shaped by their example. I still, as I'm progressing through my career, am driven by a bit of a desire to impress those original engineers.
Yeah.
Um,
It-
and
I,
and hopefully you'll be one of them too.
I still check in with those folks too. I don't check in with everybody that I've ever worked with. I mean, that would be impossible. But there's some folks that they have a glimmer of something that that you caught on to, that I try to, every 6 months or maybe once a year, just check in. And they're typically so excited to see where my career's gone. I want to know where their career has gone, what kind of interesting problems they're solving, because those are the problem solvers, right? They're always working on interesting stuff. And it's just really cool to keep those connections.
It sounds like you are practicing the 7th of the 8 core expectations, possessing interpersonal skills.
Yes, exactly. Nice.
Let's talk about the laws of software architecture. They give 2 laws. They say the first is everything in software architecture is a trade-off. Here's the quote. And they say, we also address the critically important issue of trade-off analysis. As a software developer, it's easy to become enamored with a particular technology or approach, but architects must always soberly assess the good, bad, and ugly of every choice. And virtually nothing in the world offers convenient binary choices. Everything is a trade-off. Given this pragmatic perspective, we strive to eliminate value judgments about technology and instead focus on analyzing trade-offs to equip our readers with an analytic eye toward technology choices. I love this. Nathan, what do you think about this quote?
Yeah, it rings true. And I think this is one of the things that you always should bring to the table when a system doesn't seem like it makes sense. When you look and go, how did we build this, or why is it this way? Understanding, I was at the first GopherCon. This is 2014. I'm going to do a little anecdotal story here. It's the first GopherCon in 2014 in Denver, and the Go core team was there. And one of the core team members is a guy named Brad Fitz. He worked on the HTTP library. He's also known for the fact that he wrote Memcached. He was the CTO at LiveJournal before that, but he was working at Google, working on Go. And they were playing pool, and he brought up the fact that anytime he walks into a new code base, he always tries to have empathy, starting with the assumption that smart people under constraints made this design decision that served them the best they could at that time. And if you start with that, you always can, you should take that approach before assuming an idiot did this, or these people don't understand what they're doing. And yeah, it's really important idea that everything's a trade-off. And then you should always ask yourself, is this trade-off still serving us well? Right? Like, that's the real question. That's what a real architect does, is this still serving us well, or is this actually inducing pain? Is this causing problems? And I love this. It makes total sense that it's the first law.
We've discussed this on the podcast, but I love the Amazon Principal Engineering Group. One of their tenets as a group is respect what came before.
Yep.
And realizing that, just like you said, smart people built this, and they might have been under some particular constraints. Heck, they might have just, been tired or not had their coffee for the day when they made that decision, right? But that doesn't mean that, we're all subject to the same follies. And so respecting what came before and realizing, like you said, everything is a trade-off. It's important. And it's important not to approach these decisions with that kind of high-mindedness. I like what they say. We soberly assess the good, bad, and ugly of everything, of every choice. And we eliminate value judgments. I was thinking a lot while reading this book, and particularly this principle. the idea of Chesterton's fence. I believe that's what it's called. And if you've never heard of Chesterton's fence, it's the idea that you might come across in the middle of a field a single section of fencing. It's not, you can walk around it, it doesn't look like it's serving any purpose. And so someone might come along and say, we should take down this fence. And you say, okay, why? And they say, well, because it's not doing anything. And the response in kind of the Chesterton's fence scenario is, you can't take down that fence until you tell me what it's doing or what it was built to do. Because fences don't spring up out of nowhere. Fences are hard work. When someone built that fence, they had a reason for building it. And so until we know what the purpose of that fence was, we cannot remove it. And I think about that when reading this book, that they say later on that if you have not identified the negative in a trade-off, or if you haven't identified the negative in a choice, then it's just more likely that you haven't come across it, not that there is no negative to the trade-off. And I feel that way with the fence, right? Like, until you can tell me what the bad thing about the choice you're about to make is, we can't make that choice.
Yep. And this gets back to the navigating unknown unknowns, right? So I'm a huge fan of the Chesterton's fence story, so I'm really glad you brought it up. I've actually written about this on my Substack a while back, and it feeds right into this idea of trade-offs, and that you actually can cause harm, right? If you remove the fence, you think it's not doing anything, but you realize that really what that fence is doing is blocking. You have a cabbage patch in your backyard, and that there are goats that come out in the middle of the night, and you've just never seen them because you've been asleep in the middle of the night every night. And you take the fence down, and now your cabbages are all gone, right? There's these side effects, and I've seen this too with a mistake that junior engineers, especially, and me in different parts of my career, where I hate this. I want this new tool. I'm going to put this in. I rip out some other piece that I don't really understand, and then I unintentionally broke something else, and it's very embarrassing, right? And then that's this lack of understanding of that there's trade-offs, right? Somebody made the decision, maybe it's not serving us well anymore, and we should amend that. But it's the fact that this is the first law, and they go back to this, right, over and over and over in the book. They'll be like, oh, and the first law is that there's always a trade-off, right? Like they keep referencing this, which I love. We should get into the second law.
Let's talk about it. The second law is why is more important than how. Nathan, what do you think about this?
Again, wonderful guiding principle. I talk about this a lot with our team, which is that I'm interested in patterns over tools. Like, somebody might come up and be like, I want to use Circle CI, or I want to use some specific, testing framework. And I always push back on, well, what's the pattern that we're trying to introduce, right? And that's the why. This is more eloquently said, I think, for a general use case. But why you're doing something versus how you're doing something. Sure, it might be that the why is there, and then there's an immediate answer on the how. Like, oh, okay, we're going to use this tool because we want to do this thing. But we should always get back to the why. The why should always be what's driving us as far as any design decision that we're making and any architectural decision that we're making. And it makes you think upfront, right? Because I think, again, we can easily get mixed up in our tools. And I've seen this, right? The wanderlust of, I'm going to use Kafka. Well, why are you using Kafka? Well, I read this really cool blog post about Kafka. Well, Kafka might be absolutely the right choice. Like that we're not arguing you don't need some like really cool topic-based event system. But you shouldn't pick it because, right? That gets into, I guess there's another thing, much like with Chesterton's fence, is what they call cargo cults, right? Are you familiar with this term?
I know the term, and I should know what it means, but I don't.
No, this is great. So David Attenborough, of all people, right? So he's like, the narrator on every great animal documentary and nature documentary out in the world. David Attenborough, many, many years ago, like after World War II, went to this island in an Asian Pacific island that was used as like this landing zone for Allied forces who were going to fly missions out in World War II. And when they arrived, the people on this island had maintained the airfield and had maintained some of the other stuff that was there. And it turned out that this tribe realized that the troops would drop cargo shipments to the military was actually stationed there, and they built all this stuff to do military work. And they thought, as an outside observer, well, if I perform these rituals, if I maintain this field, if I think their shaman would like use the radio system. They would, march and imitate a lot of the behaviors, and they believe that cargo would drop from the sky. If they did all these behaviors, if they tracked all these things, cargo would drop from the sky. And so they called this the cargo cult. They said, if I behave like this outcome that I want. And so this gets into the idea that like, oh, well, I'm a startup. I want to be Twitter scale. And so therefore, if I use distributed Redis, I'll get to Twitter scale.
Uh-huh.
And you're like, no, that's not how this works. Why is Twitter using distributed Redis to solve this problem, right? Like that's the real question. Not if I do this, then all of a sudden I can do, a million transactions per second or some crazy thing. And so anyway, I think this is another one of these anecdotal things of what happens if you swap those. If you start with the how versus the why, it's a cautionary tale. And but I would love to hear your thoughts on the second law as well.
We as software engineers are obsessed with the how. We love nothing more than the how. The why sometimes comes second. There's a balance, right? You talk about how you don't want to look at Twitter and say they use distributed Redis, so we should use distributed Redis. At the same time, I do think you can find a bit of a North Star in looking at companies that are doing things well and trying to imitate them. But that's because you're trying to address the why and you're looking for hows out of the world of existing solutions, right?
Exactly.
I worked at a fun, I use that word liberally, little startup, where the release process was an absolute nightmare. They would release like every 2 weeks, and it was always this huge affair, and they had to do it in the middle of the night, and it would take hours. And I'm telling you, the product was not that complicated. And I just remember I was really interested at that point in my career in CI/CD stuff. And I was reading about it because I was just looking at that process. I was like, this is insane. This cannot be the right way to do this. So I'm looking at that why, kind of like this is too much work. We're not able to iterate as fast as we can. It's a big pain coordinating things for release. We got to make this simpler. And so I was reading, Amazon at the time was publishing kind of like a state of CI/CD at Amazon report. And I remember reading that they were doing like 8,000 deployments a day across all of Amazon.
Right.
And I just remember going to my boss, who was sympathetic. She didn't like this release nightmare anyhow. She was a VP, and anyhow, that was a fun little company. Maybe we'll hear more about them as the podcast continues.
I love it.
Anyway, I went to her. She was sympathetic to my concerns, and I just said, I was like, Amazon deploys 8,000 times a day. If Amazon can deploy 8,000 times a day, there's no reason we can't deploy like 3 times a day. So I think there's a lot of value in looking to companies for that kind of North Star and saying, okay, this is how the successful players are doing it.
Right.
We should do it that way too. But again, you're looking at it, you're not approaching from a cargo cult perspective. You're saying, we have this problem. This problem has been solved in the past. How are the successful players solving it? And let's try to learn from what they're doing. I think this gets kind of into the idea of technical breadth, which I'd love to spend more time talking about. Nathan, is there anything you want to cover from kind of these first laws and second laws before we move on to technical breadth?
No, I think one quick riff on that is, the cargo cult approach would be, if we take our broken release process and do it 8,000 times a day, then we'll be like Amazon, right? But you're right. If it's a why-driven approach, it says, hey, how did Amazon structure themselves so they could safely do 8,000 deploys a day, right? What pattern are we missing here, right? And again, there's plenty of evidence. I do a lot of developer experience driven initiatives at our company. And we know that there's a positive correlation between the more frequently a team can release with how productive their engineers feel and how safe those releases are, right? I talk about this a lot, which is that any scary part of your process is actually where you need to fix your code, right? If you're scared of the change management piece, if you're scared of the release cycle, if you're scared of unit tests, that's exactly where you need to go in and fix stuff. And you need to really ask why, right? Why am I scared of unit tests? Why does this break every time we do a database schema update or something? That's exactly where the software architect needs to go in and be like, this is a solvable problem. Somebody out there's done this, right? We need to go and get down to the nitty gritty of why. And so, yeah.
I love what you just said about if you're scared of doing this, that's a sign that something needs to change.
Yep.
When I worked at a major cloud provider, our product was deployed across like 35 different regions, 400 hosts, and it was a breeze deploying it. You clicked a button, and I'm not saying there weren't hiccups every now and again, but for the most part, it just rolled out and was fine. That was the result of a lot of careful engineering up until that point. But it's why, as I've gone to work at other companies, I like having that North Star because I've seen that this is a solution that exists. And now I know it's a tool in the toolkit. And this is something we could do if we wanted, if the trade-offs make sense. That gets a bit into the idea of technical breadth. We're going to talk about all that and more right after this break. And we are back. Thank you so much for listening to the podcast. We want to talk a bit about chapter 2. You might be thinking, oh my gosh, we're still in chapter 1 and chapter 2. But it just goes to show this is a great book. We have so much we could talk about. And we are, like we said, there were 8 core patterns or principles of being an architect. We talked about like 3 of them. So if you're enjoying the discussion or wish we were talking more about something else, pick up the book, read it. There's so much great stuff in here. But chapter 2 covers architectural thinking. I mentioned this before, they talk about this concept of technical breadth. They say, basically, they talk about a pyramid of knowledge, right? At the top of the pyramid is going to be the things you know. That's going to be your technical depth, right? This might be if you're a React developer, you know React really well. If you're a Java developer, you know Java really well. You might be really familiar with AWS or Azure. That's kind of the stuff that you know, right? Then they say, as you kind of go further down the pyramid, you wind up with your known unknowns. These are the things you know you don't know. So let's take AWS for an example, right? You might know about AWS Redshift, and you know that it is some sort of data processing tool, but you're not exactly sure what it does, right? You might be familiar with Lambdas. You've heard of it before, and you've kind of heard of this idea of serverless architecture, but you've actually never built out a serverless architecture using API Gateway and Lambdas. But you know that it is an option out there that exists. They say that's your known unknowns. And then the scary bottom part of the pyramid is the unknown unknowns. This is the stuff you don't even know that you know. They say that middle section of the pyramid, so they say the top section, the stuff you know, that's your technical depth. They say that middle section, the stuff you know you don't know, is your technical breadth. And they say as a software architect, your job is to pretty aggressively expand your technical breadth, to move stuff from the bottom of that pyramid, the unknown unknowns, up into the middle of the pyramid, the unknown or the known unknowns. Here's how they word it. They say, an effective software architect should be aggressive in seeking out opportunities to gain experience in multiple languages, platforms, and technologies. A good way of mastering this expectation is to focus on technical breadth rather than technical depth. Technical breadth includes the stuff you know about, but not at a detailed level, combined with the stuff you know a lot about. For example, it is far more valuable for an architect to be familiar with 10 different caching products and the associated pros and cons of each, rather than be an expert in only one of them. I love this because this is kind of where my career has naturally gravitated, and I think it's one of my stronger qualities as an engineer. But Nathan, I wanted to get your take on this idea of technical breadth.
I'm in the same boat. I end up I'm on the platform engineering team, and so we're having to look at these sort of meta patterns all the time. I always love it when the engineering leadership comes to us and says, hey, we're trying to solve this problem. And they know more times than not, we've seen a bunch of these patterns before, and it's the breadth of, okay, understanding these trade-offs, here's what I think would actually be good. And I take a lot of pride in that. I think it's also interesting because the known unknowns as a measure of your breadth is beautifully put, because I think this is I think we've talked about this before, this Dunning-Kruger effect, right? So the Dunning-Kruger effect is this idea that you are overconfident in the things that you actually aren't knowledgeable about, right? So when you're super beginner, you're like, I don't know anything, so you have no confidence. And when you're spent years becoming an expert at something, you're confident and it's actually qualified. But there's this gap in between where you have a false sense of confidence that you actually know more than you do.
You're
And there's this
describing me about 3 years into my career.
Yes, exactly. Well, and I think all of us do this, right? And well, this is also like why you see like a plucky politician who's like maybe a really great doctor who also thinks that they can set economic policy, and you're like, that's Dunning-Kruger, right? So the I think we always think that maybe there's transferable skills that we're not quite ready for. And so this journey of breadth of knowledge is a very humbling one, because you start overconfident, and then you get all this humbling unknown unknowns that you're like, oh my gosh, I didn't understand the complexity of what I'm actually taking on. And then you learn, okay, well, here's all these trade-offs, here's all these things that are in place. And so yeah, again, I read this book and just kept nodding my head. And I think, again, one of the things that's worth spending the extra time in these first couple of chapters is this book does a beautiful job of building on all of these. It spends the time equipping you with these ways of thinking, and then they start throwing in these, here's a problem, here's a case study, here's these things, and they go back and reference these things. So I think spending the time really exploring these ways of describing our approach is incredibly useful. And I think you'll see it's going to pay off when we kind of get through the rest of the chapters in this discussion.
Like I said, this is kind of where I gravitate towards as an engineer. I have always loved knowing a little bit about a lot of things. I think it's why I'm kind of a bit of a Twitter addict, because I love just the exposure, the broad exposure to lots of different ideas. Whether that's in technology or politics or philosophy or economics or anything. I love just getting lots of different takes from lots of different sources. And then from there, I can kind of synthesize where I might stand on any given issue. So I've always kind of been this way with technology. I'm a bit of a jack of all trades and a master of none, which is not to say that we don't value technical depth. Obviously, that's a huge component of being a software engineer. It's something I'm trying to do better in my career. This book, in some ways, is kind of a funny parallel to our book last week, What is ChatGPT Doing and Why Does It Work by Stephen Wolfram, because that was a deep dive on one particular topic. And last week, I had mentioned how that's something I'm trying to be better about in my career, is more deeply understanding the tools I'm using, because I kind of naturally sit here. I like to know a little bit about a lot of different things. And I think it's something you see in this podcast. I've had some people come to me and say, hey, podcast sounds great. You're reading a book a week or 200 pages a week. You can't possibly be synthesizing all of that information. And the truth is, you're probably right to a degree. I don't think we're remembering everything we read from these books, but we are reducing our list of unknown unknowns. We're moving more stuff from that into our known unknowns.
Right.
Like we said, this book has a lot of architecture patterns, and it's great. I'm not saying I understand the nitty gritty of every bit of those architecture patterns and all the trade-offs associated with them, but they're in my brain now. And now I can identify some of those patterns I've come across in the wild and say, oh yeah, that was a microkernel pattern. And when I come across patterns in the future, I'll be able to remember some of the stuff I learned in this book and apply it to working with those architectural patterns. Or even if you just know and say, yeah, this is again, like a microkernel architecture, I'll just pick up this book again and I'll just read the microkernel section in depth.
Exactly.
But that comes from having a lot of technical breadth. So I think there really is so much value to being a well-versed individual, a modern day, a technological renaissance man, right? I always love reading about like Thomas Jefferson, who had all of this diverse group of talents and skills, right? And I always love the idea of being someone like that. And I love the idea of being someone like that within a technological niche, of having a wide degree of skills in different technologies. And does that mean, like, would I love to say, like, oh, I'm the Python guy? I know everything there is to know about Python. I'm a whiz with it. Sure, I'd love that too, but I'm not. And at a certain point, you have to choose what you're going to focus on. And for
Yep.
me, I've decided to focus on breadth. And so it's been nice reading this book and getting a bit of a reassurance that that is a valid.
I love that. And this actually fits really well into an anti-pattern that can also come out of this, which they call the frozen caveman. And
I love this.
I had never put words to this. And I'll say I'm 40, right? So I'm a little further into my career. And this is an absolute fear of mine is
Uh,
that I get frozen in time. I have some way of solving a problem, and I come in, and it's they really mention it that someone reverts back to an irrational concern that they have, right? And so they have this knee jerk reaction, and they're stuck in an old way of solving problems. Um, and I've done
Before
this
we go
before.
on,
Yeah.
do you mind if I read from the book how they
Yes,
define the
please.
frozen
Yes,
caveman
yes,
pattern?
yes, yes. I love that.
Yes. They say a behavioral anti-pattern commonly observed in the wild, the frozen caveman anti-pattern, describes an architect who always reverts back to their pet irrational concern for every architecture. For example, one of Neal's colleagues worked on a system that featured a centralized architecture, yet each time they delivered the design to the client architects, the persistent question was, but what if we lose Italy? Several years before, a freak communication problem had prevented headquarters from communicating with its stores in Italy, causing great inconvenience. While the chances of a recurrence were extremely small, the architects had become obsessed about this particular architectural characteristic. Generally, this anti-pattern manifests in architects who have been burned in the past by a poor decision or unexpected occurrence, making them particularly cautious in the future. While risk assessment is important, it should be realistic as well. Understanding the difference between genuine versus perceived technical risk is part of the ongoing learning process for architects. Thinking like an architect requires overcoming these frozen caveman ideas and experiences, seeing other solutions, and asking more relevant questions.
Yeah, it's
I
well
think
put.
you had mentioned maybe a story or an anecdote you wanted to share.
Yeah, well, I ran into this a couple of ways. With this FDA regulated medical device, there's a lot of scar tissue from folks who've gone through the regulatory process in the past. And so sometimes it was really difficult for us to figure out, is this an actual requirement from the FDA? Or is this a fear that an irrational fear that we might fail the review process because of some experience that they've had in the past? And are we bending over backwards with something that's actually handled categorically with like modern, software practices and things like this? And so we constantly had to go over it. I'm trying to think of a time that I used. I I think I actually extended the frozen caveman thing as well to tools that we're using, especially with like CI/CD processes. How we publish artifacts. There's just new ways of thinking about stuff. And if you go back and you use your old tooling, it might be incompatible with the idea that like, well, if I solve problems the old way, where we do a release every 2 weeks, and that's the way it has to be done because it's the only way to do quality gates, because there's no way, unless you have QA manually reviewing something for a week, how could you ever sign off that the thing is done properly? When if you invert this, right, and you say, no, if we make it so easy to do a rollback on an individual change, and that the teams themselves can actually push this through, and that you build it, you own it. These basic principles that we put in place, you can release 8,000 times a day, right? We can make our process more resilient. We can have blameless postmortems. You put all these new ideas into place so that the system actually becomes incredibly resilient, instead of it being that, okay, we put more and more scar tissue in between us and the customer, and all these, rituals that shouldn't be there. Um, I think this gets us back to this frozen caveman idea, which is we should learn from our past experiences, but we can't let it cripple our decision making process. And it's something we should always. You don't want to. I should say, I don't want to be the frozen caveman, right? I don't want to do that. And so, how do I keep my thinking open minded enough so that if a new idea comes in or something radical, I stay on top of trends, I stay on top of tools, I stay on top of these case studies from companies that have done things with success. I should let that shatter my thinking and reform this instead of going back to an old bag of tricks, right?
I think what's so dangerous about the frozen caveman anti-pattern is that it's it's kind of foolishness masquerading as wisdom. I think we talk about some of the principles in this book, right? Like recognize the value of trade-offs or be humble about what came before. And you can recognize the kernel of truth in that, right? That's a very like Western, even Christian concept, right? The idea of like don't be proud. And so you can take that, and that's something you've kind of been taught for decades, and then you can just say, okay, I'm just going to apply that to my career, and that makes sense. It kind of rings true to you. The thing about this frozen caveman anti-pattern is that in a lot of ways it makes sense to think like this. In a lot of ways, that's something we value as a culture, is learn from your mistakes and don't make those same mistakes again. But then you wind up like these people who say, well, what if we lose Italy? And that seems very wise. That seems, this is the battle hardened scar tissue memory of hard won experiences. And so you say, these are the wise among us, the people who've been here a long time, the people who know the problems that could occur, and we're planning around those problems, right? I think if I were a junior engineer working under these engineers when starting out, I would view these people as very seasoned and wise. And I'm sure they were in a lot of other ways. But in this particular mode of thinking, it's not very wise, because we are losing that ability to make trade-offs. It goes against the central philosophy of this book, which is that everything is a trade-off. And if we start having these sacred cows and saying, we're just going to do it this way because that's the way we did it when I was frozen as a caveman, we lose that ability to critically analyze the pros and cons of any given decision we might make.
Yep.
Well, Nathan, anything more you want to say about chapter 2, these kind of these different ways of architectural thinking?
No, I think we covered it really well.
Well, we're going to take a quick break then. We'll be back with more from this book. Like I said, we covered just the first 2 chapters. So much great stuff in this book. We really encourage you to pick up a copy of it yourself, The Fundamentals of Software Architecture. But we will be back to talk more about it after a quick break. And we are back. Thank you so much for tuning in. We want to talk a bit about chapter 3 now. Chapter 3 is all about modularity. Nathan, this chapter really resonated with you. So why don't you talk to us about why this chapter was such a great read?
Modularity is fascinating to me. It really gives us this ability to encapsulate complexity, much like what we talked about in the software design, the philosophy of software design book.
And by John Ousterhout, if you haven't read it.
Exactly, and we have another episode that actually covers this.
We do. It's a great episode.
So in the book, for the architectural perspective, they actually say understanding modularity in its many incarnations in the development platform of choice is critical for architects. And for me, it really covers these ways of thinking about how you couple parts of the system. And they actually have 3 categories that I'd never thought of before. One is called cohesion, which refers to the extent of the parts of the module that should be contained within the same module. So these are things that you want to have stuck together. They talk about coupling, right, which is a measure of the number of connections between components, right? And so a lot of times you'll hear about loosely coupled systems, why this is a good design. Sometimes, though, we want tight coupling, and they give us really good ways of thinking about what should be tightly coupled, what should be loosely coupled, what are the trade-offs. And then there's another term I'd never heard this word before, connascence. The connascence is 2 components are connascent if a change in one would require the other to be modified in order to maintain the correctness of the system. And at first you're like, oh my gosh, this means tightly coupled, right? We want to avoid connascence as much as humanly possible. But they actually say all these things are going to be connected somehow, but that there's static connascence and that there's dynamic connascence. And dynamic connascence is hard to reason about. It's really complicated. And those are the ones that parts of your system are together, but it's really hard to understand because maybe it's dynamic in the running system. Where if you can have static connascence, there's this hierarchy to that from a maintainability and modularity standpoint. It becomes really powerful. And I think anyone who has understood good like class hierarchy, inheritance, interface design, we understand that connascence of name, for instance, is a really powerful system. I can encapsulate all the complexity of a part of a system, but as long as I understand the name, the way to call something, then I get these black boxes. I can actually have connascence by name. So if I change one name, it's going to affect the other parts of the system, but we can lean on tools like modern IDEs. If I need to change the name of something, that's trivial. I can go through and refactor all calls of something within a code base versus if I have some condescends of algorithm or condescends of function signature or something uh, where the dynamic inner workings of something can affect other parts of the system. And so they basically argue that you should try to convert strong forms of condescends into weaker forms of condescends. Right? So using names is a way for us to abstract away all the complexity versus dynamic, where maybe everything relies on some sort of file caching system. And so if you change the file caching system, it breaks contracts with a bunch of other parts of the system. And so yeah, again, this chapter, we won't go into more detail on it. It's really great deep dive into how you should structure the relationship between things and how you can support modularity in large scale systems.
It was nice reading this chapter because I think we all have a bit of an intuitive sense when you look at a code base and think like, oh, this code is a big jumble of spaghetti, or oh, this code is really beautifully designed. This book puts a lot of definitions to why you might be feeling those things. So chapter 3, modularity. This is a great chapter to read if you want to, again, have a little more rationale behind your feelings when you look at a code base and say, oh, this is a great code base, or oh, this code base isn't so great or so great. It's a great chapter for that. When moving on with chapters 4, 5, 6, and 7, you can tell now we're covering a lot of ground.
Right. Yep.
We start talking about architecture characteristics. I love what they say. Nathan, you touched on this earlier. You never shoot for the best architecture, but rather the least worst architecture. And like everything that this book talks about, every decision you make when designing software architecture is a trade-off. They provide some great categories as a way to analyze those trade-offs. They call them the ilities. They call them architecture characteristics, right? I'm going to go through them pretty quickly along with how they define them. So they say availability, how long the system will need to be available, if 24/7 steps need to be in place to allow the system to be up and running quickly in case of any failure. Continuity, disaster recovery capability. Performance includes stress testing, peak analysis, analysis of the frequency of functions used, capacity required, and response times. Performance acceptance sometimes requires an exercise of its own, taking months to complete. Recoverability, business continuity requirements, e.g., in case of a disaster, how quickly is the system required to be online again? This will affect the backup strategy and requirements for duplicated hardware. Reliability/safety. Assess if the system needs to be fail-safe or if it is mission critical in a way that affects lives. If it fails, will it cost the company large sums of money? Robustness. Ability to handle error and boundary conditions while running if the internet connection goes down or if there's a power outage or hardware failure. Scalability. Ability for the system to perform and operate as the number of users or requests increases. And they say that there's some other and these are just the operational architecture characteristics. There's so many more. They talk about configurability, extensibility, installability, leverageability. I mean, we could read all of this, but there are so many different architecture characteristics they define, and they kind of say that they're always a bit in tension with one another.
Yep. Absolutely. I mean, this is two things come up from this section. Again, it gets back to that first principle, which is there's always trade-offs, right? You can't, if you have a perfectly secure system, well, one way to do this is to air gap it and not even run a website, right? That's not an option, right? So the trade-off is you have to run a website. So therefore you have to make security considerations that are also matched with the business needs of how do you run your shopping cart? How easy do you make it for the customer to get on? One of the things that I loved here is how do you prepare for all of these? How do you get ready to look at the trade-offs that you're going to have to make? You have all of these requirements, all these ilities that you have to think about. And this gets us into the Katas pattern, which I
loved this.
Yes.
Let's read straight from the source what an architectural kata is. Because like you said, Nathan, we don't work on greenfield projects a lot. It's kind of rare that we stand up software architecture from the very beginning, but we want to keep these muscles sharp. We want to be ready to design world-class architectures whenever the time comes. So how do we do that? They developed a curriculum so to speak. They say to provide a curriculum for aspiring architects, Ted, one of their coworkers, created the first architecture Katas site, which your authors Neal and Mark adapted and updated. The basic premise of the Kata exercise provides architect with a problem stated in domain terms and additional context, things that might not appear in requirements yet impact design. Small teams work together for 45 minutes on a design, then show results to the other groups who vote on who came up with the best architecture. True to its original purpose, architectural katas provide a useful laboratory for aspiring architects. This sounds like so much fun to me.
Me too.
Like, I want to start doing this in my work. And they give some great examples. Like, they talk about like a sandwich shop, and they list all of the requirements for it. Like, okay, users need to be able to place orders online. We kind of want to do this on the cheap, you know, things like that. They talk about like an auction website. They even list like kind of like meta business considerations, like we might be acquiring other auction companies soon. And they talk about how that kind of fits into that might change the kind of architecture you design. I think this is a fascinating idea. I haven't seen this in my career done. Nathan, I mean, you're the one who brought it up. I guess, why did this kind of ring true to you?
Yeah, I love this. I mean, we've done for compliance stuff, we've done things like war room sessions or testing out disaster recovery and things like this. Those are very prescriptive. I love this because they actually said this fits perfectly into a brown bag session, right?
Mm-hmm.
You only need an hour of somebody's time. You can take a long lunch, feed a bunch of folks, and whiteboard out some scenarios. And it gives you the opportunity for the more senior talent to inspire and influence a way of critically thinking about systems, right? I love this. I think we're going to steal this and try to use it on our platform engineering side because um, we're working on internal developer platforms. That's like the big trend that you're trying to do. And so you want teams to be able to be self-serve. A brown bag lunch where we throw in some snags that potentially a software engineering team would have to deal with. And then we say, here's the tools that we have. How would you approach this? I think that's such a valuable way to, 45-minute lunch to avoid wasting 3 sprint cycles. It seems like a huge win.
I love this. Work remote and have worked remote since the pandemic. I always like to say I'm not anti-office. I'm anti-commute.
Me too.
I do enjoy. I'm actually traveling to Toronto next week for a big company-wide conference. It's the company's 20th anniversary, and so we're all getting together. It's going to be tons of fun. Ordinarily, we're all remote, but I always say with remote work that one of the challenges with it is that you need to formalize a lot of informal things from being in the office, right? That even comes down to things like small talk or chit chat or just getting to know your coworkers, things that are going to come along naturally just by nature of being in the same room together. You've got to formalize. This is one of those things. I think in-person companies aren't necessarily doing a good job with this either, but this is a great way to formalize this architectural thinking. If you have a really intellectual or excited group, these conversations might happen over lunch naturally, but this is a great way to sit everyone down and say, okay, let's practice thinking like an architect for now. And I think this could be great in person, but I was just struck when reading this, I'm like, oh, this would be a great practice for my remote team too. This is going to force us to block off some time and really think like this. And again, just kind of with that idea of keeping that skill sharp, we don't design greenfield projects very often. So it's good. We have to practice sometimes. We, not in the exact same capacity, but we were struggling with this at that cloud provider I worked at, where we found out that our operational knowledge wasn't nearly as strong as we would like it to be. We weren't great at incident recovery. It was a really big product, and you would only go on call once every 8 weeks or so. And it just wasn't enough to really become familiar with every possible way that it could break. And something I said when we were discussing this problem, I just said, like, look, some of the smartest people in the world work here. We're not dumb, and we're really, really good at the stuff we have to do really often. We just don't have to do this incident response stuff really often, right? We're usually doing like day-to-day feature development and delivery. So the question is, how do we practice this stuff more often? And we never got around to it. Because we were doing kind of more structured stuff like game days. But I really wanted, this is a big, fast moving company. And so we never got around to this. I wish we had. I really wanted to implement almost like a D&D session for
Yeah.
incident response, right? Like, okay,
Yep.
this incident happened. What do we do? And even if you're not actually physically typing out the commands on your keyboard, but just kind of walking through and developing in your mind these maps of, okay, this incident happened when we kind of ran the D&D session before, we did this, this, and this. And you're prepared with those tools. It's the same with these architectural katas, where you're not actually going to build out the architecture, but taking 45 minutes to discuss all the possible approaches and then discussing with the different teams the approaches they took, I think it's a great way of thinking like an architect
Yep.
and keeping those skills current, because I think software architecture skills can really atrophy if you're not in that space very often. And we just, by nature of our jobs, are not in that space very often. We're not designing new systems every day. A lot of our job is maintenance of existing systems. So I think some dedicated, fun practice like this, because I really do think this would be fun, could be really valuable to you and your team.
I think another area that this leads to, right? So first we talked about defining the characteristics, which are objective ways that we could say, availability, continuity, these things. The readiness, which is these katas, so that we know how to solve these types of problems. That third area, and this gets into this really cool concept called fitness functions, is this idea of measuring and governing these architectural characteristics. And this one really resonated with me. It's probably because of my discipline, being in a background from DevOps and SRE. I had never thought of it from a software architecture standpoint, though, which is that metrics, monitors, unit testing, chaos engineering, all these ways that we can poke and prod to see if the system's actually functioning are actually ways for us to set expectations of the behavior of a system. And that, a lot of our breadth of knowledge with architecture is we actually aren't the ones doing the implementation of these tools, right? We are actually having to set standards and expectations for others to build in the framework that we're advocating. And I'd never thought of it, but again, this goes back to like the IDP, this internal developer platform pattern. One of the big parts of these tools is something called scorecards, where you rate a service on its readiness. And so a lot of times they'll give it like a broad silver, gold sort of rating, or you can give it some sort of percentage. But if you look at it in the architecture standpoint, you say, hey, look, to be gold rated, you've had no more than one sev zero within the last 90 days or something, right, for your service, or that you have code coverage above some certain threshold, or that you have active monitors that meet some operational standard that we have. These things are, I'd never thought of using the DevOps methodology as a way to drive architectural correctness. And so I'd love to hear your thoughts on this section, and especially with fitness functions.
Well, I love this idea of fitness functions. To take the author's definition, they say a fitness function is any mechanism that provides an objective integrity assessment of some architecture characteristic or combination of architecture characteristics. And we've discussed this in the past. I love when we can kind of automate these decisions away. Like, I think we talked about it in our refactoring episode, but we talked about like automatic linting on pull requests, because then you only need to get consensus once. Or I think
Right.
it was the practice programming, either way. You only need to get consensus once. You only need to get everyone to agree to the linting rules once, and then the robot takes care of it for you. And so the PR isn't me saying, am I going to waste political capital, nitpicking formatting issues, because that you're not doing it anymore. The robot's doing it because you already got buy-in one time. I think it's similar here with these fitness functions. You get buy-in once from people and say, okay, do we agree that these standards are something that we want to abide by, right? Do we agree that P99 latency should never breach 100 milliseconds, something like that? And then you get that buy-in once, you build the mechanisms to enforce these fitness functions, and then when they're sounding off in the future, it's not there's less time for an argument, because imagine you hadn't agreed to that. Imagine you hadn't agreed that P99 latency should never be more than 100 milliseconds, right? And now it's just kind of your pet issue, and it keeps coming up, and you keep saying, hey, P99 latency is up. There's room for disagreement, for argument. People can say, well, yeah, it's up, but do we really care about that? Or we have more important things to work about. You get the buy-in once, you formalize and mechanize that buy-in, and then you let the fitness function and the automatic tooling around the fitness function enforce the standards. I think it's a great way to it's combining that kind of technical knowledge with the interpersonal skills
Right.
that they mentioned earlier in the book, right? And I think when we think about interpersonal skills, it's not just being able to navigate a conversation well. Obviously, that's a huge part of it, right? But it's also designing tools to avoid conflict, right? When you're building something to make relationships easier within your development team, that is in a way interpersonal skills. And I think fitness functions kind of encapsulate that method of thinking.
Yeah, exactly. I had never thought of the metrics monitoring, unit testing, and chaos engineering as having a single bucket that those are in.
Uh-huh.
And now that I have a way to describe this, we say, hey, look, is this fit? Is this fit? Are the goals that we have set here meeting expectations? Do we have an objective way of measuring this? And it's important to have this conversation, right? And I know we probably don't have time to get too much into it, but this is one of the things I loved about the innovative thinking at Netflix, right? They talk about this in the
book. Do you mind if I read that anecdote real quick from the book?
Oh, please go for it.
Yes, because I love this too. So they talk about the simian army that Netflix has. They say, when Netflix decided to move its operations to Amazon's cloud, the architects worried over the fact that they no longer had control over operations. What happens if a defect appears operationally? To solve this problem, they spawned the discipline of chaos engineering with the original Chaos Monkey and eventually the Simian Army. The Chaos Monkey simulated general chaos within the production environment to see how well their system would endure it. Latency was a problem with some AWS instances, thus the Chaos Monkey would simulate high latency, which was such a problem they eventually created a specialized monkey for it, the Latency Monkey. Tools such as the Chaos Kong, which simulates an entire Amazon data center failure, helped Netflix avoid such outages when they occurred for real. Chaos engineering offers an interesting new perspective on architecture. It's not a question of if something will eventually break, but when. Anticipating those breakages and tests to prevent them makes systems much more robust.
Yeah. These stories are legendary, and I've seen very few companies actually operate at this level. I mean, some of these will actually run in production. They will force certain failures to happen to ensure that resiliency is meeting certain requirements. I think it was actually in the Google SRE book, which would be a really cool one to read in the future.
Add it to the backlog.
They talk about systems becoming too reliable so that they never fail and that they actually can't test these failure scenarios. And so they would actually induce failure states to make sure that they operated within SLA, right? They have to operate within the service level agreement, but that they needed to actually make them more faulty so that they could ensure that the resiliency was still there. And again, it fits beautifully into this idea of fitness function, which is not the way it's described in the SRE book, but I think gives a wonderful framework to think about how this is part of the system.
It takes some of those arguments off the table, right? Because then when the system crashes, say we didn't have chaos monkeys, right? The system crashes on its own. You can argue and say, well, okay, but the only reason it crashed is because so-and-so did this thing, right? And you're not really tackling the problem. When you have something like the chaos monkey, we've all agreed and said, hey, this is important to us, so we're going to design a monkey to break it. And then when the chaos monkey breaks it, there's no excuse. You say, we've already agreed that we need to be resilient. We've designed this mechanism to test our resiliency, and you're not living up to it. And that's not a problem. We're not blaming anyone here. We just need to be agreed on what the problem is and then move forward. I've never worked at a place that has its own real deal chaos monkeys. I have worked at some places where some coworkers have nobly taken on the responsibility of being the chaos monkey. I don't think anyone asked them to, but just their natural workings in the code base cause a lot of these these sorts of issues.
We're rolling this out for the first time with one of our internal projects that has these really high standards that we've agreed to in an SLA with one of our customers, and we build custom software for the airline industry. And so we're holding ourselves to this standard. And it's been fascinating because the tooling around it requires a lot of thought itself, right? We have to think about these failure scenarios. So, I think this actually feeds into another really important part of this section, the last little piece of the chapter 7, is this idea of scoping architectural characteristics. So this is one that, again, kind of ties in these concepts together. And they talk about how you need to consider coupling and condescends, right, when you're building these pieces. But they also bring up this, one of my favorite terms in the book, which is architectural quantum. Architectural quantum is this independently deployable artifact with high functional cohesion and synchronous condescends. And the idea here is that it's independently deployable, has high functional cohesion, and this synchronous condescends is, this is how you describe whether something should be living together or not, right? If I have to deploy the whole system, well, my architectural quantum is a monolith, right? The whole thing has to happen. And maybe it's that 2-week ritual where every little thing has to be just perfect for the whole system to function. Or can we start thinking about sort of component-based thinking, where maybe I break out into, something like microservices or these other architectural design decisions where I can say, look, what if I can just like have a unit here and it can deploy as much as it wants, independent of the rest of the system? And this gets us into this, the last chapter, which is chapter 8 on component-based thinking. This is the last chapter before we get into really diving into architectural styles. And again, everything's a trade-off, right? We get back to the first principle, but it's this idea of like, how do we break up a structure? And I love what they talk about here. They talk about layered architecture, the modular monolith, technical partitioning, and domain partitioning. And again, they lay out these arguments that maybe I want to break up my business logic. We've all heard about this, right? Like the model view controller, the MVC model, very popular in like Ruby on Rails and a bunch of these other web frameworks. It has a really nice, clear delineation in how business logic functions, but it doesn't really address things like domain partitioning, which is, well, what if you're on the checkout, the pricing team or the shopping cart team? Well, maybe you need to be able to operate independently because of teams. And before I get your input on this, they kind of wrap all this up with Conway's law, which again,
I love Conway's law.
Exactly. So he says, organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations, right? So they're basically arguing you're going to build a system set up by the way that your team actually functions, right? If your company thinks of itself in this hierarchical monolith, and that's how you're going to build software, right? If your team is radically independent from one another, then you're going to build software that's radically independent and has to have some other coordination step. And that,
as an example, he says, for example, if your company, if you had all your front-end developers reported to one manager, and then all your back-end developers report to one manager, and then all your database developers report to one manager, you are going to build a sort of layered architecture where the front end doesn't know about the back end, which doesn't know about the database, right? But if you are, and these are the teams where I've worked on, where if every team, you're like on the checkout team, right? And that has front end and back end and database developers all on it, then you might build more of a domain partitioned architecture. But to try to switch between the twos without changing the way the teams are structured is foolhardy, is basically what Conway's law says.
And I love this from a software architecture standpoint, because I've been in enough startups to understand this, that Conway's law is the biggest driver, right? I've been on teams that use monolithic, we use monorepos, where every ounce of code in the entire organization is in a single code base. And I've been in one where it's a repo per service. Both of them are actually great. Both of them work really well depending on the team, right? One team where the monolith was amazing, the leadership was very monolithic. And the way that we structured things, we always were very collaborative and thought about really juicy problems early in the process. And that was a perfect fit. And I've been on other teams where they really wanted independence, the ability for folks to just independently work and not have to coordinate and not have to deal with the central person. And we actually used a service-based architecture, and we were radically separated. We were obsessed with social contracts. So we said, I will never break the API, right? That was like to be independent, we had to have these other like agreements upon how we could behave. radically independently. And again, this idea of component-based thinking, this idea of picking the modularity and the structure that fits the team is very freeing. It gets back into these trade-offs in a beautiful way. I think it's a perfect way to wrap up part one of this book.
I agree 100%. And I think it plays into the central theme of this book that it's all related, right? That you can't discuss software architecture without discussing team structure. You can't discuss coding decisions without discussing the interpersonal relationships between the developers. Part of being an architect, in fact, the key component of being an architect is being able to take in all of these considerations, evaluate the trade-offs, and come up with holistic decisions that move your team forward. We're going to take a quick break. We'll be back with our final thoughts on part one of the fundamentals of software architecture. Okay, so we're coming to the end of our discussion of the first part of fundamentals of software architecture. This is a recurring theme throughout the podcast that we can talk for 90 minutes about something and we still just barely scratch the surface of everything there is in the book. We love that you're here along for the ride with us, listening to us discuss the books. We hope that you're gaining something of value. But if you're ever listening to this podcast and thinking, oh, I would have loved to learn more about like chapter 5, we kind of glossed over it, pick up the book, read it. You will learn so much from diving in and actually reading the books because we're learning so much too. And it's just really been a blast talking about them. Kind of the whole point of the reading these books is to, like we say at the top of each episode, to improve our craft as software engineers. So I always like to end the episode reflecting on what are we going to do differently in our careers as a result of reading this book. In this case, what are we going to do differently in our careers as a result of reading the first half of the fundamentals of software architecture? Nathan, what are your thoughts?
Yeah. So I've run into a lot of these concepts before in the wild, but I'd never spelled out clearly the reasoning of where these trade-offs are. So I think I'm going to spend more time exploring various architecture patterns. This is really motivated me to think more deeply. And also, I really want to use katas. Like I want to experiment with a brown bag lunch, virtual brown bag lunch, because we're all remote, and get the team to really try to dig into these juicy problems in a contained way. So I know that's how I'm going to try to drive my growth on this part.
I took that away too. I really want to do these architectural katas. Maybe I'll try to link it in the episode description, but they have a website that lists the architectural katas. If I don't link it, just search fundamentals of a software architecture katas. You'll find it. I want to use some of these katas and even take it a step further. Like I said, how I want to do the kind of like those D&D incident recovery sessions at that cloud provider. That really is just a kata. So I think even if you're not doing an architecture kata, if there's some problem that your team is struggling with, you could probably adapt this to fit your team's needs. Yeah, I thought the katas were really fascinating. So I think that's the concrete thing I'm going to take away. And then more nebulously, I just want to be better about, as I'm working with different systems, defining what kind of architectural patterns they're using. That way I can kind of have a good jumping off point for what the trade-offs for those patterns might be. We didn't get in this episode to discussing those different architectural patterns. We're going to talk a lot about those next week. And we hope you join us for that. Now, this is funny because we usually say who we would recommend this book to, and we're still going to do that. We're only halfway through the book. So I guess, Nathan, who would, after having read this first half of the book, right now, who are you thinking you'd recommend this book to?
Yeah, so I thought this book took a beautiful balance between sort of the pragmatic and prescriptive pieces that are in refactoring that we had read, and the more philosophical debates, like in the philosophy of software design. And so anyone who's serious about their IC, individual contributor career path, anyone who has aspirations to getting to senior staff principal, this is a must read. I think that software engineers who want to have that deeper understanding, architectural trade-offs, who want to start thinking about the larger ways of solving business problems. I also think this would be really useful for DevOps folks. Just because that's my background as well, breadth of knowledge is so important for understanding how to support the architectural decisions that are in place, that, having a better vocabulary, understanding the philosophical system as to why decisions are being made and not just how they're going to be implemented, would be huge for anyone on that career trajectory as well.
Absolutely. I felt the same way. Basically, anyone who works a lot with software architecture or wants to be working a lot with software architecture is who I would recommend this book to. I don't want to give any misconceptions to anyone listening to the podcast that we think that you can just read a bunch of books and then that'll make you a great software engineer. Obviously, your skills are going to come from practice, from work experience. But like this book talks about, you want to be reducing that list of unknown unknowns and converting them into known unknowns. And that is where I think reading a lot of books really helps. So if you are someone who is moving up in your individual contributor career, like Nathan says, you're getting a little more senior, but you're starting to realize, wait a minute, I don't know as much about like software architecture as I'd like. I'm really good at incident response. I'm really good at feature delivery, but like designing something greenfield, I don't even know where to start. See, like I said, that's a huge kind of unknown unknown for you at this point. It's like a bit of a known unknown, but basically you have this general idea that software architecture is a thing. You don't even know how you would design a system. Pick up this book, read it. And again, your ultimate expertise in software architecture is going to come from building functioning systems in the future. But this book's going to give you a great head start. It's going to help you define the shape of the problem and you'll feel more comfortable working in this problem space. Also, it's overkill, but like system design interviews, if you have a system design interview coming up or just want to be prepared for when you're ultimately doing system design interviews, this book is going to give you so many more choices to work from and a better understanding of what goes into a great system design. And so when you're actually building it out in the interview, I mean, your interviewers are going to be impressed if you're talking about the trade-offs between availability and reliability and scalability and elasticity. And if you're designing something and saying, oh, you know what, this is a microkernel architecture. I'm going to go with a service-based architecture here. So that's going to look like this, right? If I were an interviewer, that would be impressive to me.
So, yeah, 100% agreed. I think if you're really serious about the system interview, this would build a wonderful foundation for how.
If you've got one tomorrow, don't read this book because it's too long. But right. Like if you're someone who's thinking, oh, you know what, I'm actually going to look for a job in a year or so, read this book because this would be a great foundation for.
You'd also be a better interviewer in the systems
Absolutely.
interview, right?
Absolutely.
Yep. So.
Great. Well, thank you so much for joining us. We're going to be back next week with the second half of Fundamentals of Software Architecture. Thank you for tuning in. Like I always say, you can contact us at contact@bookoverflow.io. You can find us on social media. We are Book Overflow Pod on Twitter. You can also find Nathan's YouTube channel where he hosts his own monthly podcast called Functionally Imperative. That's on YouTube. Just look up Functionally Imperative. And you can also find us on YouTube. We are Book Overflow Pod on YouTube as well. Please like, subscribe, leave a comment, rate us 5 stars, anything you do to engage with the podcast. We're really at the early stages of this podcast, and a lot of the direction of it is going to be informed by user feedback. If you feel like we're moving too fast, tell us. If you feel like we're moving too slow, tell us. We really just want to deliver the best content we can and help every software engineer become a little better at their craft. Thank you so much for tuning in, and we'll be back at you next week with the second half of this book.
Awesome. See you next week.